So now we move on to basically lists. So it's these three. And I probably went a little bit far in the video previous with objects as references and reference mechanisms, because these are the ones that actually get into lists. So you really will have to know, and maybe that's what I'll do with this video, is I will talk my way through some of these actual algorithms in Java. But first of all, identify the features of the abstract data type list. And we've seen this before in yesterday's topic 5 and a little bit with the previous video. And this is the best of the 3 links here to look through the video and again what I did yesterday, but this answers best the features of a list. Features are that each node can find the next node, and through the ways that I discussed yesterday, you can delete or modify or search for data through the list. But at the fundamental level, lists are made up of nodes, and nodes can find each other. They can find each other because they have self-referential parts to them, along with the data that they carry. Applications of lists. Basically, you can use them as stacks or as queues, either in a last in, first out, which is a stack, or a first in, first out, which is a queue. And so that's it. And I've gone over that before, and there's lots on that here. So how do you apply lists? Those two ways. And you can also just have a list as a list, that you don't necessarily have to work with one end or another. But that is a good point to make. I'm not so sure that's made here, and I'm making a note to myself to expand on this D.4.8. Lists only as stack and queue. It's not a good idea to use a list for any other purpose. If you wanted to have a long list, say of 100,000 items, and you were going to be searching for stuff in the middle, that's silly, because every time you look through it, it's going to have to be a sequential search. You'd rather have an array that you can do your binary search. So really, the applications of lists should only be as stacks and queues, where you are only accessing from one end or the other. So the difference between a static implementation of a list and one that's using object references, I don't know. I really don't know what they mean. So if somebody else using this video can explain it, great, but we'll jump straight to the object references, which is the one that you normally will see. And I'm going to do the animation, only I'm going to be videotaping myself going through the animation, which explains how it works. And this is all based on the code that you'll find here. And I think the animation, though, is the best way to go about it. So here we go. Creating a linked list, and popping off the top, thereby treating the list as a stack. So I have a template class called IT_degree, and I'm making a new one. There it is. And remember then that an object is basically a reference. So my degree 1 is a reference. It's a reference to all the degree 1 stuff. There you go. So what is the degree 1? It is a object, and an object is basically an address. Sure, it's pointing to stuff, but the degree 1 itself, this new IT degree, it is 111 AAA. That's what is stored there, and it's pointing to 111 AAA. And I make a couple of others. And they are all references to where the information is. Now I'm going to make a list of them so that they can find each other. So I make a new list. The list itself is going to be a reference. And so I use in the list, I've got a node, which is going to be the head, or the first. And when I call the constructor of list, the head starts off being nothing. So there's the head. It's a place in memory. It's called head. It's not pointing anywhere quite yet. But now, the list has a head. So this list simply has a node it's keeping track of, which is the header. Right now, it's just nothing. Null. So we have constructed a list. And the list just is a head pointing nowhere. So now, to this list, we are going to insert at the front degree 1. We're going to insert this. So here's our insert at front. Takes in an object, which is basically an address. Makes a new node with it. So we're going to see what that does. So there's going to be a new node of the node class. So the list class is different from the IT degree class, which is different from the node class. But the node class is part of the list. But we got to make it. So we're in the middle of making this new node. It's going to take in degree 1 as the object. And so the data is going to be this, but actually the data is an object, and so the data actually is an address. And the next starts off being null, because it's not pointing anywhere. Right now we have a list of one thing. After having made the new node, we're going to make it point to the head. But the head is null at this point, because this is the very first node. And then we declare this one, the head, to be the new node. So we're saying that the head is this. So the list knows how to find the head. There's only one, but that is the head. So now we have a list of 1. We can add another one, degree 2. We're going to add this as being the second thing in the list. So the thing is, this has to be able to find degree 2. So we do insert at front, make a new node. Here it is. The new node is going to be data, which is going to be degree 2, because that's what we sent. We sent the object, right, to be the new node. The next is null for now, until, so the new node, we're going to set next to be the head. So it's going to be able to point to the head. So next is going to point to this, which is actually right here. So now, this is seen as being the head. So the list is going to start by going to the head. What is it? It's this one. It's the one that we just inserted at the front. And when it's going to try to find the next in line, it'll be able to, because its next is that very first one that we had inserted. Now we're going to insert a third one. I'll do it a little bit more quickly. A new node, make a new node. Its data is going to be degree 3, which is actually the address of degree 3, but its next is going to point to the current head. So that's going to become 1, 2, 1, 2, 1, 2, so we can find it. Right now. All right, sorry, not 1, 2, 1, 2, 1, 2. It's going to be where this begins, which is 777, 7FF. And the head is going to be changed from being what was the second head to now being the current head, which is going to be CCC444. And we made our list. The list knows what the head is. The head is this, with a certain data, degree 3. You can find the next in the list, which is 777FF, right there. And that one has data, which is here. But can find the next, which is that. It has certain data. And doesn't point anywhere because it's at the end of the list. And that's what this is going to show you. So I'll stop talking, you just click through it. And if we go further, I'm not so sure that you need this, but I might as well add it. Removing the first node in a linked list. This is the first node, so we wanted to pop it off the top. This is our PEZ. It was the last one in. If we wanted to pop it off, basically, the head's got to point to here and orphan this, as it were. Just cut it off, right? So basically all we're going to do is change the head to not be pointing to that, but to be pointing to that. Popping off the stack. Remove first. I'm going to quickly go through this because I'm not sure it's part of the new curriculum. Okay, so basically through these lines, the head changed to now pointing to the second one. And this one, it's still there in memory, but nothing can access it. Because the list points to that, points to that, points to that. So the list now just has these two. Popped off. And then we've got the address of the one that was popped off, so if we wanted to get the city or whatever, we could work with it. Output prop. So of the 15 hours, what I just did is about 3. I did it in 15 minutes. And that was that one. That was both of those, actually. So we'll stop there and then go on to our collections.